Okay, and we are back. So, in the last video, what I did was I was hoping that Copilot was going to give us a step-by-step implementation guide on how to create an A/B testing specified specifically for the project which I have. And AI Copilot went a little bit, it was a little bit eager. So, instead of creating the document, it decided, not only will I create the document, that's kind of an afterthought. No, what I'm going to do is go in, I'm going to change everything. I'm going to, not everything, but it made the changes itself. And then, okay, I'll create a document. You told me to create a document. I'll create a document of what I did. Okay. I was kind of hoping that we would be able to go in, look at step by step, and I'll show you what I was hoping it would do. So here's the document that it created after the fact that it did everything. This is what I was hoping that it was going to create, something like this, like a step by step guide with table of contents, introduction, all of this, and then the packages, the structure overview, right? And then how to do all of this stuff, and then the actual code, but the actual code in the step-by-step guide, not in my actual project. When it initially created this step-by-step guide, it didn't create the project at all. I had to go in and I created everything, which is exactly what I was wanting because I want to learn while I'm doing this. But okay, fine, 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 fine. There's multiple things that I'm trying to learn in this project. Number one is obviously I'm trying to be able to learn software engineering skill sets, the C sharp, object oriented programming, uh, the pipelines of how to do uh, like pull requests, be able to do GitHub actions, all of these things, right? The specific skills that I'm learning with the project. Another thing, which is just as real, that I am also trying to learn is how do I effectively use artificial intelligence, specifically agentic artificial intelligence. And so this kind of was a good lesson like, okay, well, it did not do what I was hoping for it to do. I was hoping for one action to be taken. It took a different action. All right, that means that there's something wrong in my prompt. And now, next time I do a prompt, I'm going to have to think about okay, let's be a little bit more specific and let's take a little bit of time to prompt it correctly so that we get the correct output. All right, so that was one thing. But now, how are we going to be moving forward? So it already made those changes, and I'm thinking I'm just gonna roll with it because I could just obviously revert those changes. It's not on the main branch, so I could just switch back to the main branch, delete that testing or feature branch, and then it would be like nothing happened. Then we can go back into AI and do the prompt correctly. But I just want to roll with it. Okay, fine, fine. Sounds good. So what I'm going to do is I am going to look at this guide that it did, right? So it did create a guide and try to understand about A/B testing, about what the changes it made are, and then I am going to go into the code, the actual project itself, and say, all right, okay, so you made these changes. Great. What changes did you make? What does it mean? And then if we get stuck and we have questions, we can go to ChatGPT and ask some follow-up questions and just figure out what's going on. So, awesome. Let's take a sip of coffee and start going. I forget which cup I'm on. Is this third or fourth or fifth? I don't know. It's fourth. It's fourth. Okay. That's important. Okay. Anyways, let's just jump right into it. All right. Are you guys ready to learn about A/B testing? I am. Woo! Setting up our own A/B test. That's pretty cool. Another thing before I just jump into this, another thing that I do want to mention is so our project is fundamentally it is a bid engine to be able to select advertisements and then serve that back to the client. Okay. But the way that I've implemented it so far, though it's very much I don't know if it lends itself to A/B testing. I don't know. I want to make what I am doing is having two bid engine algorithms and doing A/B testing on those. But I feel like I need to make my, how do I even express that? I just feel like the fundamental underlying thing is fairly simplistic, and I don't know, because that's another thing that I'm trying to learn is, okay, I have a project. How do I create a larger scale project? Because all of my projects that I've done in school, everything is sequential. Everything is step 1, step 2, step 3, step 4, right? It's just a procedural code. It doesn't matter if it's an object oriented programming language like Python, for example. It has objects, but it's still, I write it as procedural. And it's essentially just one file. Just hand in your homework assignment, you're good. And then at work, I am more of an embedded systems engineer, and all of my day is essentially spent looking at electrical data sheets and trying to figure out, okay, I have this component here. I want to write a value into that register. Which value should I write into that register? So that's my work. And now that I'm doing projects, that is something that I'm purposefully trying to learn about is how do I even structure this? I don't know if I've structured it correctly, if the SQL tables are correct. I mean, the Copilot kind of did that, right? And then I investigated it. That's why I'm trying to have Copilot use it more as kind of like a senior engineer to teach me because otherwise I'm kind of lost at sea and I'm trying to develop out from this amateur position that I'm in and trying to look, okay, well, how do I make a more complex system? And so when I'm looking at my system now, I'm like, well, I don't know if the structure of the SQL, the structure of my project, the structure of everything is the way it should be. And so I'm slightly hesitant on all of this, but I don't have a reason to be hesitant because I don't know. And it's kind of like that you don't know what you don't know. And so I'm like, I don't know if I'm doing this correctly, but I'm learning a lot, which means that we need to keep going forward. Okay. All right. This guide explains how to set up, run, and analyze A/B test experiments for different bid selection algorithms in this project. Okay, so for different bid selection algorithms in this project, meaning the algorithms that we just created 3 videos ago, 4 videos ago. Yeah, it was today. I've done 4 videos today. So, uh, yeah, we just created a secondary bid engine, a bid selector here, and here it is. Algorithm number 1, well, this is the previous one that we had, and then algorithm number 2 is down here. So this is the one that I wrote today. And then, let's see, did Copilot change anything in this one? I'm not seeing anything being changed here necessarily. Okay. This is a change. Yes. Because I wrote this function as well. This has changed. I had previously nothing with Prometheus. All of this changed. Okay. So there's been some changes to bid selector, so we will need to know that. And then they also, Copilot added new unit tests for us. And I believe an integration test because, oh wait, no, never mind. That one is one which I skipped. I purposefully skipped it because it's no longer valid. All right, so that's what we are doing our A/B experiments on, which is those two bid engine algorithms. It includes conceptual explanations, step-by-step instructions, the code I added, which again, I wasn't hoping that it was going to add it. I was hoping that it would put it here in the document, and recommended next steps and best practices. Okay. So, A/B testing is a method to compare two or more variations of a system to determine which one performs better for a chosen metric. So yeah, we need to figure out what metric are we even going to be uh, using? The other thing, so I have a lot of thoughts which are coming into my head. I'm trying to organize everything because I feel like this project is moving extremely quickly, which is amazing, and I'm learning a lot, which is also amazing. But a lot of change is going to be a lot of like chaos, you know. So I'm thinking, okay, the thought that just came into my head is I should probably, even though this is a back end project, I should create a front end that actually has the ads. I should do that full pipeline. And I should have an image URL. And okay, that's actually a good point. I should not just have this random back end. I should write a front end to connect to it. Yes. Okay, that is something I want to do in the future. Okay. Just making a mental note of it. I don't think I need to write that down. We'll remember it. Okay. Famous last words. Let's write it down. We'll remember. Okay. Create a full front end and to actually request and get served ad. Create ad instances. Because right now we have random data which is filled in to the SQL for the ads. So the ads have all of their fields, right? And we stored that in an SQL database. It's all there. But some of the things which were like image URL. Okay, well, we can put a fake URL there. But if we're actually now going to force ourselves to write a front end, I'll need to figure out how to actually do that, right? Um, okay, so some future directions. It's written down now, so there we go. All right. Anyways, you split traffic between variants, control, and treatment. Okay, so A and B. Measure key metrics and use statistical tests. And then what I could do is I could even do another A/B test, a different A/B test, and do like uh, how many, if you show 1,000 of ad one and 1,000 of ad two to specific users, which ones get a higher click through rate? Which I guess that's this one, click through rate. Yeah. Okay. And use statistical tests to determine uh, whether B is better than A. Key ideas: deterministic assignments per user, stickiness, metric instrumentation, sufficient sample size, and predefined stopping criteria. Okay. So, deterministic assignment per user, stickiness. In the context of A/B testing in C#, okay. Question number 1 is, what does this mean? All right. So now, summary of the changes that I made for A/B testing. Thank you for making the changes. Very eager, very eager. I implemented a basic A/B framework and added tests so you can get started immediately. Quite considerate of you. Thank you. Files added and changed. Okay, so this one was added here. Source Bitengine services. So we have a new service, and it looks like it is a interface here for experiment service. So we are creating an interface, and experiment service. So hash experiment service probably implements this interface. Okay, so interface for experiment assignment. Okay. Deterministic hash-based assignment. So this is how we're slashing up our file or our traffic, okay? Bid selector updated to consult the experiment service and increment a basic Prometheus counter when assigning users to variants. Okay, so after I did the last video, which was I think about an hour ago, I went to go eat lunch, and while I was eating, I had my phone out and I was watching some videos, and specifically of Prometheus, because that's what the last video we were looking through this, and I saw Prometheus, and I was like, oh, okay, well, I'll learn a little bit about it. That is a front end service that attaches to like a database. Wait, no, sorry. Because it was talking about Prometheus. Grafana, no, Grafana, here we go. So it was a video about Grafana, but they were also mentioning about Prometheus. That's why my brain was mixing those two. So Grafana is the front end service that you're able to see metrics of data. Then Prometheus is a collector of that data that you're able to give. So it's an open source collector of data, like a service or a server, I should say. And then Grafana is able to communicate with Prometheus and get that information. Okay. And then display it. All right. So we are talking to Prometheus, which means that we might be able to send that to Grafana. Okay. So program.cs registers hash experiment service in dependency injection. Okay, awesome. Bitengine tests. So these are the unit tests which it did. So hash experiment service, test for assignment, test varying routing. Okay. Bid selector already had two algorithms, algorithm 1 and algorithm 2. I wired the experiment service so it deterministically selects A or B for each request. Awesome. So that is kind of what I was hoping. So yes, great, you did that. And by the way, we are going to go and look into the actual code and see how it did this. Right now I'm trying to get a higher level overview of just understanding, okay, what did it actually change? And then we can go in and look at that. Okay, so I added a simple Prometheus counter label. So there's something in Prometheus called counter label for experiment and variant to make it easy to count assignments, okay? So we are counting how many we assign to each, like, so we're assigning how much we count to each. What? Experiment? Yeah. The other thing is I'm looking at myself, and I feel like here it looks like I am just like tilted one way, and then I'm trying to correct it, and now like no, this is straight, but it looks very unstraight. Yeah, okay. Anyways, I look like I'm tilted. Whatever. Maybe, maybe I've been slouched over too much. All right, so step-by-step guide of how it works. This section walks you step by step through the implementation and how to run and measure an experiment. Decide your experimental goal and metric. All right, pick a single primary metric. Click-through rate, fill rate, revenue per milli, success rate of budget deduction. Define a hypothesis. Okay, so now we're getting into actual kind of like it's a legitimate scientific experiment, right? We do a hypothesis. Algorithm B will increase CTR by at least 5% versus algorithm A on homepage placement. And so I have a little bit of experience with A/B testing. And so the experience that I have is like this. Guess what? I make YouTube videos. I didn't know if you guys know that, but I make YouTube videos. And one of the features which YouTube allows you to do is it lets you do up to three titles for your video and up to three profile pictures for your videos or like thumbnails for your videos. And so you can upload multiple ones and it does A/B, or I guess ABC testing for each of those, and then it returns back to you which one over the course of like a month had the highest click-through rate, and you can see all of the different metrics. So I have a little bit of experience in terms of that, but now this will be the first time doing it within like software and actually setting up an experiment. So cool. But okay, right? Like algorithm B will increase CTR click through rate by at least 5% versus algorithm A on homepage placement. So you create a very measurable hypothesis. Why? Experiments without a clear primary metric and hypothesis are hard to interpret. Then, ensure deterministic sticky assignment. Okay, we added iExperimentService and HashExperimentService that deterministically assign a user to a variant A or B based on a hash of experiment name plus the identity of the user. Okay. This ensures the same user will be assigned to the same variant. Stickiness. That's what stickiness means. Okay. So if I hear someone mention about stickiness, what that means is that a user will be assigned to the same group each time. So it's deterministic. Okay, which avoids cross-contamination. Awesome. So the code added in... Okay. Code already added. Now we can go to look at the iExperiment interface. Here, which is one line, which just says it's returning a string, get variant, okay, string experiment name, string identity. Oh, which would make sense because this is an interface. So we are just defining the methods which are required for anything that implements the iExperiment interface. That makes sense. We're good. So hash experiment. Let's do a hypothesis. I expect hash experiment to implement iExperimentService, thereby it will implement getVariant method with the same decorators. Okay, let's test our hypothesis. Implements iExperimentService, First part is yes. Get variant, which is public string. So, okay, good. String, experiment name, string identity. String. We win! We win! Look at that. We won, guys. Okay. So, this is what it added. Well, it added the entire file, but... Okay. Get variant. We are going to... First off, the constructor here is going to initialize a private variable called dictionary. Okay. This is experiments. This is... Oh, okay. Experiments is a new dictionary with a key of string and a value which is a tuple of string int. Okay, so an example is no, not an example. A concrete thing which it put in there was bid selector. So bid selector is one of the experiments. So bid selector is an experiment. That's its title, is bid selector. Now the value of bid selector is A goes to 50%, B goes to 50%, okay? So this is how we're splitting up our code. Then we do get variant, and get variant is going to, if string dot is null or empty of this identity. So if we pass in an identity is anonymous. Okay, that makes sense. If configuration, what is configuration? Where is this defined? Cryptography, maybe? Try get value experiment name out var configuration. Okay. Return just control. So this is the normal one. Compute bucket. So this is the hash that we're doing. So we're gonna have compute bucket, which, okay, yep, this is creating the hash out of this, like, essentially we're seeding it, but with a number which is deterministic. Experiment name is going to stay constant for bid selector for each experiment, and then identity is going to be the same for each person. That's why we're finding this. Okay. Although if they're anonymous, then we should almost throw that out. Oops. Copilot is... Okay. So I think we would want to throw out anonymous identities because we don't want to group all identities or all people who refused to sign in together and assign them into the same group for an experiment. This would contaminate the also people who don't sign in might have similar, oh my goodness, similar qualities, and it could also group all bot traffic into the same group. So I'm going to tag myself in here like that. There we go. Okay, so just a thing that I'm noticing. Now configuration, I don't know what this is going to be. Weight A, weight B, okay. So now we know what this is. So now instead I can ask this question. Like this. Yeah, I'm just gonna ask that. And then I need to find, okay, so bucket threshold, if it is configuration, if the bucket is lower than the threshold, then we assign variant A, otherwise we assign variant B. Okay. And then return that. And what is it returning? A string. Okay. So let's see what's going on here. What you're looking at is very common A/B testing pattern in C# using a dictionary of experiment configurations to decide which group a user belongs to. Okay. So experiments, we've already seen this. Maps experiment names to their configuration. Try get value. What this does is, now I don't know about the outvar configuration. That's something that's like I'm kind of curious about. So what it does is it attempts to look up the experiment by name. Look up the experiment by name. What does that mean? If found, configuration will hold the configuration object. If not found, the method returns false. Okay, so if the name isn't in the dictionary, it'll fall black. Okay, so we're trying to find... Okay, so we're just searching the dictionary and trying to get this experiment name, seeing if we have experiment name. So that's like the key, right? Okay. But what is outvar config? Okay. So number one, what does outvar config mean? Question number two. What do you think of my comment? Question number three. So CFG will contain the value which is assigned to the key of that dictionary. So for example, config will be this. Now, weight A. How does it know weight A? Okay, so I don't see a weight A member variable. And so what is going on with this? And this. All right, let it do its thinking. And do we still have a lot more, right? Yeah. All right, so deterministic route request to different algorithms. So modify the code and choose the bidding algorithm to consult, and then call algorithm A or B accordingly. I updated bid selector, select winning bid to use the experiment service and increment an A-B experiment assignment. Prometheus counter with labels. Okay, we kind of got that. Instrument outcome metrics. So you need to measure user, visible, and business metrics. For example, impression, counter, labels, variant. Okay, click will be placement and variant. So click will have a counter of how many times it got clicked, and placement and variant are things that can change within the ad. Okay. Use Prometheus counters. We already used Prometheus in the project. Increment counters at the point where the event occurs. When an ad is eventually returned, when a click is recorded, when a budget deduction occurs. Okay. So I don't think I've implemented the ad clicked yet. Back to the thing that I was saying at the original part of this video, I need to build it out to make it more of like a fully fleshed out, legitimate project. Okay, so make another note of that. No logic for ad clicked yet. Okay, that will be something else that we need to do. Metrics, create counter, impressions, count. Okay. Oh, what is this? So I might need to do this part. Right? Just metrics. Analyze results. Basic statistical sanity. For success failure metrics, Binary outcomes use two proportional z-test to compare rates. Okay, so I'm gonna look this up. What is a z-test? Proportional z-test, and then t-test, non-parametric test, metric test. Okay. The polls metrics, important. Predefine the stopping rule and do not peak too often to avoid false positives. Type I error inflation. A simple approach is to run for a fixed time until minimum sample size is reached. Okay. If B is significantly better, gradually increase percentage of traffic to B. Example 25 to 50 to 100, or switch default. If B is worse, roll back to A to analyze results. Okay. Here are recommended improvements and best practices for production grade experiments. Configuration driven experiments. So allow experiment allocations to be configured via app setting. Okay, so this is within our actual app setting JSON file right there. So we could add a field which is experiments and then have this bid selector experiment. Okay. Then read into hash experiment service in the constructor. Okay. Hash-based assignment is stateless and stable, but if you change allocation percentages, you may want to persist prior assignments in Redis or DB. Okay, so I think what this is meaning is if we change the percentage which we put people into experiment A and experiment B, or group A and group B, if we change that percentage, it might change if person 1 used to be part of group A. Well, then if we change the percentage, now person 1 might be assigned into group B, which we don't want. We want to keep them in group A. We want that stickiness, is what it was called. Okay. So now, but if you change allocation percentage, you want to persist prior assignments in Redis. So we would use Redis to make sure that they're back into their original location. Implement Redis-backed experiment service. It checks Redis for an existing assignment first, else computes and stores it. More sophisticated traffic routing, use gradual rollouts. Okay. Robust metrics and tagging. Tag metrics, variant placement, campaign ID, and other helpful labels. Keep label dimensions small to avoid cardinal and metric stores. Okay. Experiment dashboards and analysis. Create Grafana dashboards. Okay, that's where I saw the Grafana, and that's why now that we've read through this entire thing, now it makes a lot more sense why they're talking about Grafana, because Prometheus is right there. So we're able to like get that hooked up together. For variant comparison for the primary, okay. Export raw counts periodically for offline analysis. Keep failsafe. All right. Now, what else did it do? Okay. Just seeing how much more we have to read of this document. And then how are we actually going to move forward? I need to continue to look. I think we understand this, but I don't know how it's called. That's the thing. As of right now, I don't know how this is. Well, it should be in bid selector, right? So I have bid selector here. We have not looked at this yet. Request. Identity here. And then we get that string. And then we do that. We need to look into what that does. With labels. Increment, okay. Variant B, await, select, winning bid, async. Okay. So is it equal to B? If so, do algorithm 2. Otherwise, do algorithm 1. Okay. And then these are the same. But then, so this is just splitting up the data. I have not actually implemented any experiment yet, right? Because we haven't decided about if we've clicked on, if we're doing a click event. We haven't even implemented the logic for click event, and therefore I can't implement the A/B test because I would have to implement the logic for click. Then I would have to go in, search for who is there, like who clicked it, and are they part of group A or B, and then record that within Prometheus. So far, I think what we've done is just separated our data, right? So I added unit tests to ensure deterministic assignment and routing from bid selector to the correct algorithm, okay? Recommend additional tests, integration test with Redis backend assignment if you implement it, end-to-end test that validates metrics are incremented correctly, okay? CI notes the existing GitHub action workflow runs unit tests on push and pull requests and has an additional integration with, yeah, we already know that. Okay. When adding integration tests, ensure they are stable. Okay. Minimal code examples already added to the repo. So, bid selector. Yeah, this is what we were just looking at here. This one. Okay. Select winning bid right there. And then we're assigning it. Oh wait, no, this is the... No, this is, sorry, yeah. Review the code here. Add variant labels on those metrics. Create Grafana dashboard. Okay, run a small canary experiment with 10% traffic to monitor. Okay, analyze results with statistical test. Recommend repository layout changes. So consider extracting bidding strategies behind iBidding or iBid selection strategy interface and register multiple implementations. This makes experimenting easier and isolates implementations, okay? add test helpers with builders and a test experiment service so unit tests can simulate assignments deterministically. Look at Prometheus and Grafana documentation. Okay. So, did I ask a question and it was thinking? All right. So number one, what does CFG mean? Try to get value is a method on a dictionary that tries to look up a key. Its signature is generic key, generic value. The out keyword means this method will assign a value to the variable if the key exists. Okay. CFG is shorthand for declaring the variable. Okay. CFG is shorthand for declaring the variable with the correct type inferred. The correct type inferred from the dictionary value. Okay, so that's why we do var, because it could be anything inferred from the dictionary. Okay. If the experiment name exists, experiment will be set to the corresponding value, likely experiment configuration. The comment about anonymous identities. Your comment is thoughtful and raises valid concerns. If groups all anonymous user, the risk of contaminating because of this. In practice, many A/B testing systems either exclude anonymous traffic. Yeah, that's what I was thinking. Incorrect. Okay, good. Just wanted to make sure I wasn't like way off base. Here is not a tuple. Okay. It's almost certainly an instance of a class or struct like this, and then so we just try to get value returns something here. Okay, I don't know. So when you do this here, can you walk through with me how you get back a experiment config struct? I am seeing it declared as okay, so understand the config value in my dictionary. Your experiment dictionary maps strings to C# value tuple. Yep, here. Initialization. Awesome. Even though the literal doesn't name elements, a tuple's element name comes from the field type declaration. Okay, what? Okay, hold on a second. Let me think about this. Even though the literal doesn't name elements, what is a literal? Number one, what is a literal? Name elements. What do you mean name doesn't name elements. The tuple's element names come from the field type declaration. What is a field type declaration? Okay, what is a field type declaration? That's why configuration weight A, configuration weight B, and here work their named elements of the tuple type. Experiment, get try value. Threshold is configuration weight A, weight. There's no experiment here. You're running an experiment, a named tuple. If you want actual, uses a class or record instead of a tuple. I'm just trying to understand how it even works. Okay, what is a literal? A literal is a fixed value written directly in my code. Oh, okay, okay. Oh, I see, I see. Hello, okay, awesome. What do you mean named elements? When you write a tuple literal like this, you're just giving values in order. You didn't explicitly name it. Oh, okay, yeah, that makes sense. The elements names come from the tuple type declaration in my dictionary. Okay, because the type declaration names the elements, you can later access them. Okay, if you have declared them here. Okay, what is a field type declaration? In this context, I meant the tuple type declaration, the part where you specify the types and names of the tuple elements. Okay. Oh, variant A. Oh. There it is. There it is. Okay, and we put that into the dictionary, and we have those. I'm sorry. I'm sorry for that. I should have caught on a lot quicker than I did just now, but I did not see that. Now it makes sense. There we are. Okay. I think I am going to take a little bit of a break and I'm going to go around, take a little bit of a walk actually. I've been sitting all day today and so I'm going to go out, take a little bit of a walk around the town and then come back and we're going to do more videos. I'm thinking, where do we go from here? On my walk, I'll think about where we go from here. Okay. We have a lot of studying we need to do. For example, I still want to go in and study those unit tests to understand how it set everything up. We have not looked at the integration tests yet. We need to figure out if we are going to like how we are going to monitor this, how we are going to register an event, what events we are looking for, how we connect that to Prometheus. We also, as I just mentioned, need to develop the full system of like the front end interacting with the database. Then we need to get the URL to actually do something when clicked. We have a lot to do. Okay. So I'm gonna think about this, like how we go about this in my walk, and kind of let things rattle around in my head, and I will be right back pretty soon. So yeah, thank you guys for watching. If you liked it, subscribe. I would love to have you along on the journey. My name is Timothy Lee Grant, and see you very soon.